171, Chapter 3, Derivatives. The average rate of change for a function f of x as x goes from x to x plus h is called a difference quotient and is given by the formula f of x plus h minus f of x all over h. This formula looks a little different than the formula for the slope that that you see in intermediate algebra or pre-calculus, but essentially it's the same formula. y2 minus y1 over x2 minus x1. It's the slope of the secant line, taking the limit as h goes to 0, gives a slope of a tangent line, which represents the instantaneous rate of change. It's called the derivative. It's denoted f prime of x. So here's an illustration. We can, if you just to revert to more familiar notation, this is x1, x2. This is y1 and y2. So we have the point here. The x coordinate is x1, y coordinate is y1. This is x1, y1, and then this point up here would be x2, y2. So anyway, it's the notation looks a little different, but it actually is the same. Essentially the same formula as the slope that we work with in intermediate algebra. Okay, so here we have a function f of x, and we want to apply this formula here. The average rate of change as x goes from 3 to 5, well, we could write that as f of 5 minus f of 3, f of 3 over 5 minus 3. So f of 5, if you put a 5 in here, it's 5 squared plus 5 is 30. Minus 6 times 5 is 30, so that's going to be 0. F of 3, you have 3 squared is 9. 9 minus 18 is negative 9. That'd be negative 4. And on the bottom we have 5 minus 3 is 2. So it's double negative is positive, so this is 4 over 2, which is 2. So the average rate of change as x goes from 3 to 5 then is 2. Okay, so we can also compute the average rate of change as x goes from 4 to 5. So this is going to be f of 5 minus f of 4 over 5 minus 4. The denominator is 1, so anyway, f of 5 is 0. F of 4, well, 4 squared is 16. 16 minus 24 is negative 8. Negative 8 plus 5 is negative 3. So this 0 minus a negative 3 over 1. Double negative is positive, so this is 3 over 1, which is 3. So the average rate of change as x goes from 4 to 5 is 3. So you see the slope is increasing. It was slope 2 from average rate of change, slope 2 from 3 to 5, but from 4 to 5 it's a little steeper. It's the average rate of change is 3. If we do 4.5 to 5, so that's f of 5 minus f of 4.5 over 5 minus 4.5. So the denominator is going to be 0.5. F of 5 is 0. F of 4.5. Okay, so 4.5 squared. 4.5 times 4.5. 5 times 5 is 25. Here is 2. 22. 5 times 4 is 20. 4 times 4 is 16, 18. 20.25. So this is going to be 20.25. Okay, and then 6 times 4.5. Okay, so let's add 5 to that. So if you add 5 to it, we get 25.25. And then we have minus 6 times 4.5. 4.5 times 6. 5 is 30. 4 times 6 is 24, 27. That's minus 27. So you have negative 27.00 plus 25.25, 0.75, negative 1.75 minus negative 1.75. Okay, so double negative is positive. So this is going to be 1.75 divided by 0.5. And we can divide 0.5 into 1.75, move the decimal over one place. So it's going to be a little more than 3. 3.5. Okay, so the slope, average rate of change from 4.5 to 5 then is 3.5. So this is the answer here. I'll circle the answer. We have slope 2, slope 3, and now it's up to slope 3.5. Okay. Okay, so let's compute the instantaneous rate of change. So this is going to be what's called the derivative, and this is here we want to take the limit as h goes to 0 of f of x plus h minus f of x over h. So f of x is, just a reminder, f of x is x squared minus 6x plus 5. So in the formula for f, instead of, actually I'll do this on the next line. I want to leave myself enough room here. In the formula for x, instead of x squared, we want x plus h quantity squared. Instead of 6 times x, we'll have 6 times the quantity x plus h, and copy the plus 5. And then we want to subtract f of x, so I'll just change the sign here. X squared plus 6x minus 5 over h. So before we take the limit, that's the without taking the limit, I mean that would be the slope of the secant line. That's the average rate of change. And once we take the limit, then we get the slope of the tangent line, which would be the instantaneous rate of change. So this is minus f of x, and this part here is f of x plus h. Okay, so we can cancel the 5 and the minus 5, and we can distribute the 6. We expand the x plus h quantity squared. So we can rewrite this as limit h goes to 0. This is going to be x plus h times the quantity x plus h minus 6x minus 6h minus x squared plus 6x all over h. Okay, so so I just distributed the negative 6 here, negative 6 times x, negative 6 times h. And now we can cancel the minus 6x plus 6x. That's going to be 0. And I can distribute here with the FOIL method, x times x times h times x, h times h. And that'll give me the limit h goes to 0. We'll have x squared. The outer product is xh, the inner product is xh, so we'll have 2 of those, 2xh. And then last times last plus h squared and then I'll copy these terms here, minus 6h minus x squared over h. Okay, so now we can cancel x squared minus x squared, and that'll leave us, and we can also distribute the denominator here. So the limit as h goes to 0, 2xh over h plus h squared over h minus 6h over h. Okay, so if we divide through by h, the h's will cancel on the bottom. We're left with an h in the middle term here. Give us a limit as h goes to 0, 2x plus h minus 6. So that's actually the slope of the secant line, and then if we take the limit, we get a formula for the slope of the tangent line. So this is the slope of the tangent line, or the instantaneous rate of change, is going to be 2x minus 6. So that's f prime of x. It's called the derivative, denoted f prime of x. Okay, so so now we want to use this formula to compute the instantaneous rate of change when x is equal to 5. So we found that f prime of x is equal to 2x minus 6. So f prime of 5 is going to be 2 times 5 minus 6. 10 minus 6 is going to be 4. So the instantaneous rate of change is 4. And just looking back at our answers from parts A, B, and C, we see that as we got closer to, as the points got closer together, we're getting closer and closer to 4, closer and closer to the instantaneous rate of change. So the average rate of change from as x goes from 3 to 5 was 2. The average slope there was 2. The average slope from 4 to 5 is 3. Average slope from 4.5 to 5 is 3.5. And so they're getting closer and closer to the instantaneous rate of change, which we've now computed to be 4. And that concludes this presentation.